In late 2025, developers evaluating AI capabilities rallied around a bizarre performance metric, prompting models to draw a pelican riding a bicycle. Pelicans are anatomically complicated to render, bicycles are intricate, and there was zero chance any AI lab would waste resources purposefully training a multi-million-dollar model for this exact scenario. It served as a pure, untainted test of generalized logic. Before this benchmark, using AI for real engineering work was a gamble, often referred to as often work. The outputs were impressive, but they lacked the consistent precision required for production environments. Because the tools were only often work, developers hit a production bottleneck. They spent more hours hunting down hallucinated variables and fixing logic errors than they did building new features. That bottleneck shattered in November 2025. In a single month, the title of the world's most capable model changed hands 5 separate times. The massive frontier providers, OpenAI, Google, and Anthropic, locked themselves in a high-stakes corporate war to claim the top spot. As the models grew smarter, the trajectory of AI development diverged, creating 2 incredibly powerful and distinct paths for the technology. This fracture separated AI development into 2 specific environments, one scaling up into massive corporate cloud infrastructure, and another scaling down to the consumer desktop. Up in the cloud, the frontier labs deployed a technique called reinforcement learning from verifiable rewards. They trained their models against strictly verifiable outcomes to increase the reliability of the code they produced. This pushed AI coding agents across the mostly work barrier. They transitioned into reliable daily drivers that could ship functional, complex software on the first try, without requiring constant human intervention. The economic response was immediate. Major developers like GitLab recognized that the time and cost required to produce raw software had just collapsed. GitLab reacted by flattening their organization. They announced plans to remove up to 3 layers of management in specific functions so that their leaders would be closer to the actual code. For GitLab, the collapsing cost of production is driving a structural shift, moving away from management-heavy hierarchies and towards smaller, independent teams with end-to-end ownership. Far removed from those massive corporate server farms, the second track of the revolution ignited on consumer hardware. It started with the rapid evolution of an obscure open-source repository called Werlay. By February 2026, it had exploded into a massive project operating under the name OpenClaw. This triggered the cultural emergence of claws, personal AI assistants running entirely on private machines. Many users began treating them almost like digital pets. The obsession with running local claws caused Apple Mac Minis to sell out across Silicon Valley, as developers rushed to buy what some called perfect physical aquariums for their new digital assistants. These open-weight models, projects like Qwen and GLM 5.1, began matching frontier performance on consumer hardware within months of the November inflection point. To demonstrate the leap in local capability, a compressed model running on a laptop successfully animated a highly complex prompt, a North Virginia opossum cruising down the street on an e-scooter. This bottom-up ecosystem erased the hardware barrier to entry. You no longer need access to a billion-dollar data center to run frontier-level AI logic. We are no longer waiting for the AI revolution to arrive. We are now adapting to the infrastructure it has left behind. The concept of programming language lock-in is dying. AI agents can now port entire code bases between different languages in a matter of days. This intersection illustrates the Jevons paradox in action. As the cost and friction of producing software collapses to near zero, the total market demand for new software explodes. But human engineering jobs aren't disappearing. The role is shifting from the manual creation of code to the management and direction of AI agents. But there is a final, hidden metric for survival in this agentic era: long-term code maintenance. This equation outlines the mathematical trap. If an AI agent writes code twice as fast, but doubles your maintenance burden, you have quadrupled your costs. To survive, your tools must decrease maintenance costs at the inverse rate they generate code. Blindly chasing generation speed without managing your underlying system health is a dangerous trade. You get a temporary productivity boost today in exchange for permanent digital indenture tomorrow.